I started working with mainframes in the late 70s. I'll date myself a little bit with OSVS1 and IBM Series 1s, doing real-time control in refineries at Exxon. Interesting enough, the work we were doing then was today we would call it digital twins. It was then just very expensive real-time control. A couple of years later, moved on to MVS at that time in a highly distributed system with mainframes running CICS DB2 and 23 distributed OS2 LANs running around the country, all hooked up on an SNA network in what was a pretty well-defined distributed architecture. We might call that hybrid today. That gave you a very interesting view of the challenges of that level of distribution. After that, I joined Microsoft in 1990 and switched gears and switched the perspective to working on both clients and servers, leading into the cloud. And probably for most of my career, have spent time working on architectures and architects and the distributed architectures and how to make that work, which is actually a real challenge. The cloud then subsequently becomes an introduction of another node type into that distributed architecture. But that's probably the gist of where I've spent my time, is on distributed work and distributed architectures and how to do it well. So I think when current IT leaders, managers, looking at their investment portfolio, as they think about the investment, the question is, how durable is the investment? And that sort of dictates the framework for what they do. And when you look back at the systems that they've got today, those mainframe systems, they're incredibly durable. They've been around for a long time, providing incredible value to banks, retail, insurance, healthcare, hospitality. And so the essence of what they do has been durable and long-lasting. And you've got this great asset running and really running core parts of many businesses. And the challenge is then how to actually take advantage of what's there. And so the notion of how do you take advantage of recent innovations, which tend to be happening in the cloud, the investment in both academic research as well as software companies developing great capabilities in the cloud. And the question is, how do you bring those two together and look at it? When you look at it from a financial perspective, it's the depreciation of the asset and the ability to invest and get the right kind of return on investment based on the work that you're going to do. And when you look at that portfolio, it actually says that there are places where you can take advantage of stuff, and there's places where you should actually do something new. And the mainframe really sits in that space of incredible durable value that continues to run and execute on those businesses. And then the challenge is the ability to integrate what you have into this new world to take advantage of those innovations that keep on happening. So there's this very natural way, going back to my earlier point about distributed architectures, is taking advantage of what you have in the right way, in the right format, modernizing the infrastructure that you have, but really integrating it in different ways into the capabilities that are available in different kinds of nodes and different kinds of platforms. But it doesn't in any way change the fundamental balance sheet value of the assets that you've got and how to take advantage of them. And the mainframe sits sort of central core to that, around its ability to be super successful in executing and running the business as it does, but then integrating into this broad world. On the mainframes today, you have this phenomenal collection of real-time transactional data that's a true reflection of the execution of the business at any time. But when you look at integrating that data with the disparate data that's available on other platforms, that's where we start to see huge values. And we're seeing data marketplaces being available that take different kinds of data that you as a mainframe owner might not think about being of value. But when you take the data that you've got and then integrate it with the data from these marketplaces in a very broad way, you start to see incredible new value being able to generate. For example, around a customer. The knowledge that you have a customer is your knowledge and only your knowledge. But there is significant knowledge about your customer, their preferences, their trading partners, their perspective in an open space, where if you could integrate that data with the data that you've got, now you actually get incremental, but exponentially incremental value about integrating the two pieces of data together, the data that you have and the data that you can get. The dilemma in this case is actually frankly convincing the owners of the mainframe data that their data is not complete. Their data is complete to the degree about what you know, but you don't know what you don't know until you integrate that data with the rest of the world. And so the view of being able to combine the data and then put it into various analytical engines, whether it's machine learning, it could just be basic analytics. But as soon as you get into machine learning and the ability to be predictive of behavior and look at next best actions for your customer and being predictive of their demands that they may have and planning for you, suddenly the world is changing in terms of the view that you have around your customer. And that could be customer, it could be product, it could be supplier within your environment. When it doesn't matter whether you're dealing with consumers or whether you're dealing with a B2B, that notion of better understanding of the journey is super important. And the way that that happens is through the integration of data, the data that you've got on premise today, integrated with the data that's broadly available to you and to others in the cloud today. So it's all about the data and how you use it. There have been various ways of moving data. Sometimes it's been transactional data, sometimes it's been replication. The simplicity of how you move that data and compress it, encrypt it, and move it in a simple, manageable way, but do it within the environment that you're used to. And so the way data can be accessed on the mainframe from different mainframe storage, whether it's DB2, whether it's vSAM or other data stores, bringing that data together, compressing it and encrypting it, but leaving it in the format that it's in, and then moving that using cloud-based technologies into an object store somewhere else, into a cloud. That really hasn't been done before in that mechanism. And so instead of doing an ETL where you extract, transform, and load, this is a much simpler approach, which is to extract the data from the various stores on the mainframe and then move it. So you load it and move it at high speed into another platform. And then you have the advantage of many, many different transformation engines to take advantage of that data to publish it into this new data world. So it's a slightly different view of doing it, but it's also about the management of that system and the simplicity of that system in being able to do that and then publishing it to an object store in the cloud that you now have a myriad of other tools available to you to actually operate on that data, transform it, and bring it into the sort of modern world of cloud-based analytics and business intelligence. The value is not necessarily just in sitting it. The value is firstly in the movement of the data from the mainframe into the cloud in its simplest, most reliable, compressed, encrypted format. Once it's actually in that object store in the mainframe, now it can be transformed and moved into any other environment in a sort of canonical form. So its canonical form would be the mainframe form, but then different transformation engines can take advantage of it to bring it into those other worlds. But what it does is moves the processing off the mainframe and moves that transformational processing into the cloud. Schema transformation is actually hard. 80% of schema transformation is really easy. When you take a customer number, you take an order, product, volumes. The tricky part comes in the last 5 or 10% of the transformation, and there are AI technologies today to help you do that and be predictive of the change. But 100% fidelity is actually really hard. And so the best place to actually do that would be in that cloud environment when you have access to these massive data stores and AI to be more predictive of what that schema transformation might look like to actually minimize the loss of fidelity when you do that. And so it's easy to do most of the work and it's really hard to get it done right. And that the cloud environment provides the right kind of sets of tools and technologies to be able to do that, while at the same time keeping the transportation of the data from the mainframe into the cloud simple, fast, encrypted, secure, and reliable. So I'll go back to this notion of durability, which was when you take a financial look, a sort of a balance sheet look at the assets that you have, look at that mainframe that you've got and identify what it is doing and what it is doing best. We see lots of companies modernizing applications and rewriting the applications on large projects. Not that that's not a good thing to do, but to do it in a controlled, paced fashion. But in the meantime, you've got this wonderful asset on your mainframe executing your business and doing it reliably and durably. And so when you look at the hybrid cloud, the challenge to managers and leaders today is to understand which functionality you run in which node of the network. and where you can best take advantage of the capabilities that you've got across those nodes. And so look at the assets that you've got and make those decisions as you would on a financial basis. So when you're looking at investing in the cloud, for example, you could be saying, this is going to be an experiment. It has a 3-month life. We're going to do something and identify if it works. Invest in that as if it was an expense. But when you start to invest deeply in durable asset in the cloud, you look at it more interestingly enough as more of a capital asset, which has some sort of depreciation and you expect to last longer than 3 months. The challenge is that life cycles on the mainframe were measured in tens of years, and life cycles in the cloud for assets in the cloud, because of the innovation and the rate of change, seem to be much shorter. And so the framework that I like to use is, how do you want to invest? Where do you want to invest? And how do you best leverage that investment? But you have to be honest. Financial leaders, business leaders have to be honest with themselves about the nature of the investment and the expected half-life of the investment that they're making, and then invest accordingly. Get the right people, get the right assets to do the work, but be honest with yourself about how durable you think it's going to be. It's interesting when you look at the different personas, because technologists actually prefer assets in the cloud to actually change all the time and take advantage of new capabilities. Business leaders actually want both stability and speed. They want the work to be done to be durable, but they also want to be able to take advantage of new things that happen over time. And so bringing those two audiences together, I think, is one of the key challenges of business leaders today, and understanding the framework for the investment and making the right levels of decisions. One thing I will add, though, is that as you start to experiment in the cloud, it's very important that the business leaders be part of that experimentation, rather than having the technical audience experiment and play and identify which are the big assets to use. It's the business leader that should actually own the outcome of that work and help to decide the investment framework in both financial and people and time to be able to get to those goals. When I step back and look at the work that various companies are doing around integrating their mainframe into other environments, I see sort of two discrete sets of activities. The cautious step of taking what you've got and integrating it, and then those who jump off and actually trying to do something big, trying to do something that actually will get them dramatic change, and the sort of the balance that exists between those two. And so when I step back and watch what happens, it's kind of interesting to see the outcomes that come out of that and where the individual successes are. To some degree, it depends on you as a company, your culture as a company, your ability to absorb rapid change versus more stable change. And those are the environments that I think are most interesting and challenging. So a lot of it is introspection about the nature of the company you are, and the risk levels that you have and the ability to do that. The consequence of that is that I think we'll continue to see mainframe systems continue to run as best as they can for some time. And not the lifeline to them, because they're not sort of disappearing, but the value is how you then take those systems and then integrate them into these other capabilities that are available, and sort of framing that in a very broad way. But I don't see those mainframe systems disappearing. I do see work being done changing the user experiences. So adding a modern user experience on top of those transactional systems to actually get to self-service, to get to the point where, as the user of the system, whether I'm a member of the company or whether I sit somewhere else in the value chain, to allow me to more deeply engage. And the better place to do that is actually going to be in that hybrid environment rather than in the dedicated cloud environment, both because of speed, but also because of the capability and the functionality of just being able to do it in different ways. And so integrating your users in a different way is something that has to get to this notion of the hybrid. And I see the hybrid scenario continuing for a long time. When we talk about hybrid cloud, there's lots of other hybrid solutions between work that's going on-prem and work that's going on in one or more clouds that are out there. The interesting thing that when I look back at mainframe systems that are there today, is you talk to many engineers today working on these fantastic cloud-based applications, and they sort of scorn and look at the cloud and what did it do, and the capabilities of the cloud, and then they look back at the mainframes and like, what are these mainframes, and how to use them, and use these crazy languages that are not available anymore. The real thing, the real value is some interesting work around the notion of durability of the asset. And so when I think you look back at the mainframe and what it is, what I love about the environment is the mainframe created an ecosystem for both IT infrastructure, operation and management, but also application developers, and created this application model that was exercised by millions and millions of programmers who wrote code in COBOL that wasn't very beautiful, but actually ran the businesses of the world for many, many years in a continuing way, and making it very simple to build these applications in a highly predictable manner, predictable in terms of functionality, predictable in terms of performance, and predictable in terms of management. There's a lesson to be learned there about how those systems are built and how you create this massive community of developers producing predictable solutions in a known time. And you look at what's happening in the cloud now, where you see all this energy and agility of work that's being done. And sometimes we need to step back and look at some of the things that happen on the mainframe and the benefits of that, and how we might take advantage of that and bring that forward into the modern world. But having millions of users in a sort of controlled fashion produce incredible value to those companies that have lasted so long, there's an incredible lesson to be learned there that I think we're not taking sufficient advantage of that as we think about building modern hybrid applications in the cloud and across different platforms. There are sort of very interesting scenarios about what runs best on the mainframe and what doesn't. I want to take a step back just a little bit and talk about the sort of hybrid-based scenarios. Hybrid today, when we say hybrid cloud, sometimes it's interpreted as many clouds, maybe from different vendors integrating with one another. We talk about a mainframe cloud as a hybrid. But those distributed architectures are not new. They've actually been around for many years. You actually had, if we start off with the sort of original mainframe, and then you got into distributed solutions, the example that I gave in the beginning, when we talked about OS2 LAN sitting in front of a mainframe. You actually have different kinds of scenarios where client server was a, quote, a hybrid scenario where there was work taking place on the server and work taking place on the client. You had two-tier solutions. You had client-server mainframe-based solutions. So these distributed architectures have actually been around for a long time and have been studied for a long time. And there are lessons to be learned from those environments in the architecture and the way these solutions are being built. And so as I look in and analyze various solutions and operations, one of the key things that I would look for in these hybrid views is the notion of connectivity. In other words, when you have multiple nodes participating in a distributed network, what are the assumptions about connectivity? And most engineers, when they build these systems, assume perfect connectivity between the nodes. It's always there. It's always available when you need it. Gives you infinite bandwidth and total manageability. But the truth of the matter is that's not true, is that most distributed architectures are what I'll call mostly connected. They're connected most of the time, but not all the time. And in many cases, the time that you need them to be connected, they're not. And so as you build these solutions, how are you thinking about the notion of how they're put together and the ability to actually deal with both the reliability of the distribution of capability, the management and security of that? And so when I look at the ability to take data and move that into the cloud, one of the key capabilities that I'll look for is, can you do that on a continuous basis and manage it in a secure, reliable, encrypted way as you move data between those particular platforms when you look at the hybrid view? But the lessons of the past seem to have been forgotten about as we look forward, as we build these solutions. And so building hybrid clouds today, whether they're mainframe clouds or cloud to cloud or any of those particular topologies, how you build those and how you take account of them are incredibly important. So the base functionality is valued, but it's not just the base functionality. It's the management, security, reliability, recovery, restart, resiliency. That's where the really hard work goes to. And so one needs to look at both the functional capability, but also as this operational capability of, does the hybrid system actually provide you with the value that you need continually, reliably, and predictably? And if you can solve those problems, how you integrate these platforms together, whether you're integrating distributed function or integrating distributed data, the winners and losers over time are going to be determined by their ability to both address the function as well as the operational correctness of those architectures. Model 9, a small Israeli company, is actually doing some really interesting work looking at how to integrate both the data from a resiliency perspective into the cloud, but also how to integrate that data into assets into the cloud. What they've done that I think is super interesting for me is the number processing capability that they take advantage of on the mainframe is done on what's called the zip engine, which actually does not consume mainframe MIPS, but is actually running in this coprocessor running in the mainframe framework. And in that coprocessor, an open platform, they can take advantage of both encryption, compression within that zip engine. So it actually is pulling CPU consumption off the mainframe into this coprocessor and then pushing it to the cloud in a high-speed way along a typical IP sort of open network. And in doing that, is actually freeing up capability on the mainframe to continue to do work on the mainframe, but allowing this well-integrated, well-managed connection into any cloud. And in doing that, can both work with the resiliency, the backup scenarios, but I think the real growth over time is going to be integrating that data and making that data broadly available from the mainframe into this wonderful, innovative environments that's happening in the cloud that's moving faster than many of us can deal with.